All right, good morning, everyone, and welcome to our second DC Spark Saturday event. Very pleased to present to you this event. Is actually this year, that's the second year in a row we're hosting this event, organized by Capital One, Metastream, and Databricks. We started on a very bright note today, right? So the weather is shiny. I feel a lot of spark in the air in this room as well. We have a very packed agenda today. Yesterday we had a dinner with the speakers. Heard a lot of unique use cases, different domains, from credit card to gaming to healthcare. So it's going to be a very exciting day to hear all this information today. A lot of learning, different perspective on Spark and the technologies around it. So very quickly, so my name is Yuri Bogdanov. I'm the Director of Engineering here at Capital One. I wear this nice and sparky gray T-shirt, and you will see a lot of volunteers from Capital One. Please make sure if you have any questions, ask them around. We always here, to help you this day. So now, the exhibitors, they came to talk to you today. So all the tables are open. Please don't hesitate. Stop and ask the questions. Also, the speakers will be available to answer any of your questions outside of this room after their speeches, okay? So let's get it going. I would like to, very honored and privileged to present to you the Vice President of the Capital One, Vice President of the Technology at Capital One, our heart and soul of our data transformation practices here, Krista Steno.
Well, I don't know about the heart and soul. So the clicker doesn't work for my machine, so I'm going to have to advance the slides manually, so forgive me as I go back and forth. But I'm Krista Steno. I'm a vice president here at Capital One, and I run the Streaming Data Platform initiative. So we've got an overall data transformation initiative within Capital One where we're doing real-time streaming. We're creating a single data lake as a repository for data at rest. And then we're working to enable machine learning by training models using that bulk data and streaming real-time data in to those models to get scores for things like fraud and underwriting transactions and things like that. So I want to first, last night was a lot of fun. We had a dinner. It was probably the liveliest conversation I've had with technologists in a long time. I want to thank both Databricks and Metastream for sponsoring the event. Databricks has been a great partner with Capital One for probably going on 2 years now. Metastream has been a huge advocate in the Spark industry and just the big data industry as well. So a fantastic woman-owned small business. So check them out at the booth when you get a chance. So today what I want to talk about are 5 things. I want to set the context a bit for why real-time streaming is not only advantageous, but a little bit of a journey for a company like Capital One and in general for the financial services industry. I want to then talk about where we're headed with that inside of Capital One and the types of engineering resources and sort of technologists that we need to help us get there. Then I want to talk about the architecture that we're putting in place. And in light of the meeting or dinner meeting we had last night and a lot of the discussions, what I'm going to talk about today are some prototypes that we're working on in terms of event processing down at the Enterprise Event Hub as the 5th item on the agenda. But we'll talk about how Spark fits into the overall equation. And I want to just be mindful of, at Capital One, we're using Spark in a lot of different areas. We're doing plenty of work with replacing legacy MapReduce jobs on HDFS with Spark. As I said, we've partnered up with Databricks on best practices on how to do that. We are using the Databricks notebook solution along with other notebook solutions like Zeppelin and Jupyter. But we are very much a Spark shop. And so if you are a programmer in Scala or Python and like big data, this is absolutely a great place to be. So let me go ahead and set this context. So what we are trying to do, and I think like many of the other companies in financial services, they're predominantly batch-oriented. So transactions take place throughout the day with credit cards or deposit accounts. And oftentimes, most financial services companies will reconcile those transactions at the end of the day. What we are moving toward and have already in place in different pockets within the company is the ability to stream data in real time and do underwriting. And so we wanted to talk a little bit about how we focus on our customers and the way in which we think about their lives and how they use our products. Now, how many people here work for Capital One? Can you raise your hand? Okay, so maybe a third, maybe a little less. Okay, how many people here work in financial services, to include Capital One folks? Okay, so for those of you outside of financial services, banks generally get a bad rap for customer interactions, and we're really working hard at Capital One to change that for our customers. And what we're looking to do is be able to provide our customers real-time interactions, whether it's through our mobile or web interfaces, and be able to ensure that they get the best experience using our products. And our products, in the world of products inside of Capital One, we view those as our credit cards, our bank accounts, our auto loans, our mortgage loans, those types of things. So this is a family, Nick and Katie. We'll see that they are doing routine transactions using one of their Capital One credit cards. And then they book a trip. And at this point, we get some information about that trip, just like any other credit card company would. And we're able to discern exactly where they're headed, what date, so May 8th, 2017, how much they spent on the ticket, what airport they're leaving from, what airport they're arriving to, but we don't really understand the full context of why they're taking this trip. Then we see later another purchase that's outside their normal routine spending habits, and we see that they're spending quite a bit of money at Disney.com. So we can infer that they're taking a trip, and as their credit card limit starts to get hit, as they continue to transact with the product and reach their credit card limit, they go ahead and through our mobile app initiate a money transfer to pay off that credit card. And then they continue with some routine transactions up until the point in time that they take off and fly down to Orlando. And so at this point, given that we have that historical information about when they're taking the trip, where they're headed, that can inform a bunch of things downstream, like our fraud models. For example, we should expect that we should see transactions starting in and around Orlando, Florida on that day. But then we get to a challenge. We haven't processed, because again, we're batch-oriented, we haven't processed that money market transfer, we haven't restored that line of credit, and then a moment that any credit card company would not want to have happen is they go to make a purchase, sort of spur-of-the-moment purchase, and the transaction gets declined. Now, it might get declined for fraud because you're out of your normal spending geography. In this case, it's an indication of being declined because they don't have enough credit limit left. So this is the type of thing that you don't want to have. We want to remain what we describe as first in wallet. We want to make sure that our customers can depend on our products, that if they are a good customer and they're paying their bills, we want to make sure that that credit limit doesn't become the thing that causes them to have a bad experience on a vacation, and then in turn maybe pull out a different credit card company's product. So where we're headed. Where we're headed is these items in yellow. We launched something called Eno, which is Capital One's, it's the personal financial assistant that we're building for every customer. So it's going to be an interactive experience, so it'll be fully automated, leveraging machine learning behind the scenes and these very deep and rich customer profiles and understanding what types of activities are happening with customers. And so in this case, when they're getting close to that credit limit, and we also have that information about a pending trip, Eno could initiate a chat with the customer to suggest that they pay the balance off sooner rather than later so that payment gets processed in time. Eno can process the payment directly, so you'll see on the next screen here in a bit, you'll see an interaction just that can give you the balance. We're enabling the ability through your mobile phone, through a chat experience, to be able to pay off your credit card in real time. So this is Eno. If you go to Capital One's website, you can see more details on the Eno product. But in general, you're going to be able to interact with Eno in a very natural way, the same way you might interact with a friend, and inquire about your balance, initiate payments, check to see what your last transactions were. And so the idea here is Eno needs to, for the over 70 million customers, the Eno platform needs to be able to surface the information that's most relevant for those customers in real time as you initiate those chats. Because if it's like my child, when I text him to see if he's done with his school homework, and he takes 30 minutes to respond, and I see that he's read the message, you don't want that type of experience, right? You want to be able to have Eno be really dynamic and interactive in real time. So let's talk about events and complex event processing. So when you're trying to enable streaming, it's one thing to set up a platform. Like you could install Apache Kafka in a day, get that set up, create a bunch of topics, have people produce and consume from those topics. That's fairly straightforward. The challenge that you have inside of a company like this, if you really want to try and weave together the experiences and the events that are taking place with a customer, is you've got to create an ontology that represents your business domain. And so each of our lines of business, we've got a financial services group, which is home and auto loans. We've got commercial banking. We've got our credit card company, as I'm sure you know, and our banking for deposit accounts. And so each of those lines of business, the engineering teams and the business partners have had to think long and hard about what events are most relevant to the organization. Now, we're trending toward the same mentality that Tesla has, where they instrument everything, right? And so it's better to have the data and not need it in your current modeling environment than to not have the data at all. But it's obviously something, as you're retrofitting existing systems and you're building new systems, instrumenting those systems so that they can stream events that are relevant are really critical. And then you want to make sure that you've got the same nomenclature or the same sort of semantic meaning. If I create a credit card account, the way I represent that in terms of an event should be very similar to opening or creating a bank account, for example. So complex event processing is taking these events, which represent a significant change in state, and these events are immutable. So once the event happens, once the customer clicks on make a payment on the mobile app, they may not finish making the payment, right? They might not go through all the steps of the workflow, but once they click on make the payment, the entire data ecosystem should be informed about that event. So downstream systems that care about that, whether it's customer service agents, whether it's the mobile app itself, getting that sort of feedback loop that says, okay, they've selected making the payment. You then retrieve, okay, what is their current balance? How much money, if they've linked a checking account to automatically move that money over, are there sufficient funds in that checking account to make that payment? So producers are, in the pub-sub model, producers are the systems that are responsible for generating these events, making sure that they adhere to a specification so that downstream you understand what that event represents. And the consumers have the responsibility to react to that event or not, right? So this notion that a consumer could consume that event and say, this event isn't really relevant to my downstream system, but other events may be. So where we're headed, how many people in the room have used if this, then that? Okay, so likely all around your home automation, right? Gentleman says no, probably some other cool things you're doing, right? Cool. So if this, then that, it's hard to say sometimes, fast, is the ability to string together events, and it originally started out as some very simple, what they called recipes. And now they've gotten a little bit more advanced and have this notion of applets. So you can do complex event processing where events, not only does the existence of the event have to occur, but constraints within the event, certain values. I want to know if a transaction is greater than $100 but less than $200, or if I want to know if it's more than 20 miles outside of the person's home zip code, those types of things. So we're headed in that direction, and we'll talk a little bit about that. But for those of you that haven't seen it before, let me just walk you through. If you were to go to ifttt.com, sign up. I'm not advocating it. I'm just telling you it's a free service. And you can start stringing together some things. But they do it in a very interesting way. And this is where we're headed. So you go through, and this is my account. And you'll see you can go through and choose what type of service you want to actually pay attention to. So what events that get triggered out there in the internet, what events get triggered that you care about and want to be able to respond to. So in this case, I'm going to go ahead and choose the stock ticker symbol one, so the one in the lower right-hand corner. And then what happens is once you choose that, that service exposes a bunch of microservices that say, here are the things that I can emit that you would want to consume. And you can identify the constraints in the next step. So in this case, I'm going to pay attention to the one in the upper right, which says I only care about a particular ticker symbol, and I want to be notified, or I want to be able to consume the event when the stock price goes above a certain value. So in this case, I went ahead and said, OK, I'm going to track Capital One's stock value. And at the time when I put these slides together, this is back in the spring, it was a few dollars below 83. So I thought, see how long it takes before I start getting notifications. So you go through and you say, OK, if this event happens against this ticker symbol with this constraint in terms of the dollar amount, what do I want to do next? So you go through and you say, here are the other services that are exposed that you could then have that event. Once that event occurs, the trigger then invokes one of these other services. And so I just went ahead and said, all right, we're going to connect to SMS. So I want to get a text message every time Capital One's stock price goes above $83. I can go back and update that dollar amount and increase it. But so you go in, you put in your mobile number. My mobile number is published everywhere, so I don't care if you see it here. Put in the PIN, and then go ahead. And so it creates effectively this sort of DSL, if you will. And you go through that. And so what we're looking to do inside of Capital One is be able to enable downstream consumers to respond to events and have the ability to string together a response to that in real time and do that without writing any code. So today, if I emit a new event as a producer, and there's a downstream consumer that needs to consume it, they need to understand the message format. They need to understand what constraints might apply to that event for it to be relevant to that consumer. And then they've got to write the code in order to actually take action against the event. So how are we going to do that? So I won't get into all the details of this slide. I'll probably gloss over a few. But this is the general high-level architecture of where we're headed. And so you'll have raw data coming in from, in this case, I'm indicating customer events with the item number 1 there. So mobile clicks, web clicks, transaction data, all of that is flowing in through the front door of our cloud environment. And those front door systems are instrumented with that little gray cube, which is the software development kit that we've created. We've got a version in Scala. We've got a version in Python. So if you've got an application, and we're building other ones for other programming languages, but those are the two predominant ones here inside of Capital One. If you've got a system, you use our SDK. We abstract out the underlying Kafka implementation so that if we ever wanted to port to Kinesis or another streaming platform, we'd be able to do that. That data would flow in. It's shown on item number 2. And then a series of things happen. There are the downstream consumers indicated with 3 that would consume the data. But then there's a bunch of things that happen in item 4 that we'll talk about with event processing. And so item 5 is just some things that we're doing around monitoring the control plane and admin console, or software layers that we're putting on top of Kafka to abstract things out even further and give lines of business engineers and business stakeholders the ability to see streams in real time and what's going on. And I'll probably show you a quick demo of what's going on here. But I'm going to zero in on item 4 as we move through the presentation. So this is a graphic I like to use a lot in presentations where I talk about the value of data in real time versus in aggregate. And so it's published by VoltDB. We don't use VoltDB on any of my projects, but I think the graph is really telling. So this idea that you collect a bunch of data in financial services and Facebook and other types of industries where it's really consumer driven and you're trying to understand the patterns and behaviors of your end users, the data in aggregate is really, really critical. You can discern, where do they like to shop most? What time of day, day of week do they eat out? How much do they spend on their average meal? All of these things inform not only our fraud detection, but it informs whether or not we might have a partnership opportunity with a given merchant. Right? If we have a lot of customers frequenting a particular merchant, you probably saw there was a campaign with Uber early on, way before a lot of the challenges that Uber's been through. But what's really interesting is the real-time value of data is, a single piece of data is really critical once it first arrives, but only if you can actually act on it, and act on it in a meaningful way. And so we're combining that historical view of data and that repository and sort of rich profile on customers to better understand what we can do in the moment as new data arrives. So when you define a streaming pad or a streaming layer for an entire company, as I said, you've got different lines of business, different stakeholders. You've got to come up with an ontology and a semantic meaning for all these different events. And then you've got to define the patterns that are acceptable and not acceptable for streams, right? People might want to rush and stream every piece of data that they've got. You know, when I said Tesla has instrumented everything, right? They haven't instrumented the door handle, right? They're probably not measuring whether or not the material in the door handle is fatigued and streaming that information in real time. So you've got to figure out what makes sense for your organization. And then the other issue is, what's the value of a stream relative to maybe a synchronous call to a RESTful service? So if you want to get a piece of data, and I want to get the last 30 credit card transactions for a customer, we've got a credit card transaction system that exposes an API that will give me that data, and it generally performs really well. So if you need it in a few hundred milliseconds or maybe a second, invoking that RESTful API is completely suitable. Versus, if you're a downstream consumer and on demand you want to know those 30 credit card transactions, you're not going to be listening to every credit card transaction through a stream and partitioning off those 30 for that one customer. So events that we look at are not only events notifying when a credit card transaction happens, but we have a centralized customer store for attributes about a customer. So if that customer logs into the website, updates their phone number, we want to make sure that for KYC purposes, which is know your customer, it's regulatory items there, we want to be able to make sure that all the downstream systems are updated with that new phone number. Or at least informed. They won't be storing the additional data unless they need it. Likewise, we have a command pattern that we support, which is if an event takes place and you want to have another system within Capital One perform some action on your behalf, you can send what is effectively a distributed RPC call. So here's an example out of our credit card environment where what was propagating before, events were taking place, and they were certainly taking place in real time, but the meaning, the semantic meaning was left out. And so in our credit card system, we'd get events like number 12, number 21, and things like that. Didn't mean a whole lot. We've been on this journey to get everything sort of moved into something that is more meaningful, so you can see in the middle pane here what's actually flowing through the environment now. And so as a stakeholder, I can go in and I can click on credit card account created, and I can see in real time how many credit card accounts have been created in this last narrow window of time here. So in order to get that right, you've got to have some governance as engineers. We probably don't all love that, but you've got to set up some standards. You've got to get the engineers that are producing and consuming data to adhere to those standards. So a lot of it is about making those SDKs really usable, publishing the standards, making them as lightweight as possible. And so that's what we've begun to do. So if I zero in on this area here, what we're looking to do is, as I talked about earlier, Eno needs a lot of contextual information about a customer as soon as that chat initiates. And you can't do it, you don't want to do it a priori for 70+ million customers and load up a bunch of data. But you want to be able to do it very, very quickly. And when somebody contacts Capital One, if they call into a customer service center or if they initiate a chat with Eno, we talk about this temporal blast radius, this notion that at a point in time you contact us, there are some things probably in the recent past that have happened that have caused you to initiate that, or there's something in the near future that's coming up that's got you concerned and you want to be proactive about it. So we look, and it's going to be different for every customer, but we look at this blast radius that says, okay, let's go back in time maybe 48 hours and see if there are any significant events that have happened, any anomalies in those events. Maybe there was a credit card charge in Canada when you weren't on travel, and this is just preceding that trip down to Orlando. So we look in the past, we look at what you might be doing right now. So maybe you were on the mobile application and you initiated making a payment, but you stopped. We want Capital One, the ecosystem, the downstream systems, the customer call center to understand what it was that you were doing at the time that you initiated the interaction, and then what might be coming up. So in the case, if, for the example that we showed with Nick and Katie, it could be that you called or you contacted us the day before you left because your payment hadn't posted yet and your credit limit was, still high, or the credit balance was still high. So what we're doing here with the Event Hub and how we're coupling that with Apache Spark, and as I said, last night's dinner was really informative, and it may make us go back and maybe try a different prototype and compare and sort of horse race the two. But the idea is we want to create a high-speed caching layer of events that have happened, partitioned by customer, especially when we see certain events take place in the ecosystem. So the event about booking a flight and knowing the travel dates for that person would trigger storing that event and starting to accumulate things, discarding what we view as routine events for that customer, but then trying to create sort of that profile of that customer for when they're about to go on travel, and then expecting transactions, assuming they make the flight or the flight's not canceled, that transactions start to begin to take place down in Orlando. Likewise, if we wanted to get those last 30 transactions for a customer because somebody said, hey, what's my credit card balance? And we tell them their credit card balance, to say, okay, tell us the last 30 transactions or tell me my last transactions. We want to be able to surface that data really, really fast. We're going to layer in a couple of other things that I think negate the ability to just do that microservices call and get those 30 transactions from an API call, because we're also going to decorate some of those transactions with which ones are routine. If any of them are fraudulent, we're oftentimes finding people are initiating contact with us not because they love us and want to just chat with Eno because they're bored. They contact us because they've actually got a concern. And so it's a little bit more sophisticated than just invoking that API and getting those 30 transactions. So we're creating an enterprise event hub, and that event hub, at least the prototype of it right now, is going to be leveraging Apache Ignite. And the nice things about Apache Ignite is it couples well with Apache Spark. But Apache Ignite does some things that are a little bit different. The first is, so it'll read from Kafka the same way Apache Spark will. It will allow you to create these ephemeral views of data partitioned by customer or partitioned by whatever sort of domain model that you're thinking about. But it allows you to do in-memory indexes of what are considered materialized tables. And so the other thing is it will produce Spark-compatible RDDs, but unlike Spark, and maybe Richard will educate us if there's some update to this, the Spark RDDs are immutable, and they're immutable for a reason. Spark is really a heavily analytic, in real-time environment. But what we want to be able to do is we want to be able to have these in-memory tables be updated on the fly as these transactions are taking place, because the customers don't stop using our products. When they contact us, they might be contacting us because they've actually swiped their card and it got declined, and we want to confirm that it's not fraud, and then we want them to run the transaction again, right? So we want to be able to constantly update the list of events that are associated with that customer and then pass those into Spark, which is what we have used predominantly for most of our monetization efforts to enable real-time machine learning and things like that. So we've got a bunch of Spark jobs that are out there running. We're going to, as a result of last night's dinner, we're going to take a look at a couple of different things. But in general, what we're looking for is those mutable RDDs that can be updated with new events, really fast SQL queries against the data. Our fraud models, for example, will want to know how much fraud has there been within a given state within the last 4 hours. So fraud rings tend to operate in states, or somebody steals a credit card and starts using that within a given state. So a lot of real-time updates going through there. So here's how it would look if you'd extract out one of the nodes down there in the lower left-hand corner. You'd have this is an architecture using co-located Spark and Apache Ignite. So we would pull data in from the SDP using the Kafka Connect strategy. We'd feed that data into an Ignite node. The Ignite node would create these shared RDDs. That shared memory space is available to all the Spark jobs, and moreover, it's not ephemeral. It doesn't go away. So subsequent Spark jobs, once the first job runs, long-running jobs would have access to that data, and subsequent Spark jobs would have access to that data as well. So very quickly, I'll show you a demo or just give you a view of our production system that just came online at the end of August. So we're only a little over a month in. Well, not even that. We're not even a month in. So I'll give you some sense of the amount of volume that's flowing through some of the systems, and one sort of late-breaking thing, which is kind of cool. But we are hiring, just like I'm sure all the other sponsors here. So if you're interested, by all means, feel free to email me directly. We've got a booth outside as well. And let me just switch over and show you some information. So we are using Grafana. So here's one view, and if you're looking at, so this platform went live at the end of August, so we're a little over 2 weeks in. We've got what is that trending up to? About 4.8 billion records flowing through one of the clusters. If you recall the architecture diagram, we're stamping out different Kafka clusters for different resiliency purposes, trying to maintain separation of concern for some of the data. We're also making sure that no one cluster can bring down the entire organization. If we get to, when we get to a point where we're streaming all these critical events, the last thing that I want to be known for is the team that brought down Capital One's transaction processing. So we're segmenting things out. I'll show you a couple other clusters that are online now. So this one is the one that I had in the demo. So we can drill down. Well, that'll give you a sense, right? When you create a new account with us, you got to give us your address. But so in just, it's a number of accounts, 265,000 roughly. So lots of accounts flowing through, and then sort of late breaking news, a new use case came on with their own cluster, and that's this weekend, so you can see 120 messages having been sent. We're monitoring things. We're building out our monitoring suite. We're building out our self-service suite. Cool.